All right, guys, those of you at home, this is the video for today's lab, the 4-7 Pulley Lab. In this video, we're going to be looking at a few different setups of pulley systems and recording some data. So if you are going to modules, you should see a document there that you will fill out, and then once you fill that out, you will submit it. But that is going to be our lab today, is looking at these pulley systems. Now, the first pulley that we are starting with is on the paper, it's called the pulley number 5. In this pulley, there are 2 fixed pulleys and 2 movable pulleys. And you see they're called that because these ones that move up and down are the movable ones. These are the fixed ones. Okay, so this is pulley number 5. Now, on your paper, you see the first thing that's wanting you to record down is the number of strings that are being pulled up. Now, as you look at this pulley, and as it gets pulled down, the object here, which is a weight, as it's getting pulled up, there are 2 different strings that are getting pulled up as well. So that's that first part of that table. Now, the next part of that table is asking for the output force. And I'll come back to that. Let's do the output distance and input distance next. So the output distance is going to be how far this pulley lifts the object. And so if we take a meter stick here and we record how far it moves, we see that it goes from, where did it start? So it started at 17.5 and went up to 28.5 centimeters. 17.5 went up to 28. So that means that it increased by 10.5 centimeters. So on your table, the output distance, which is the distance the machine lifts the weight, is going to be 10.5 centimeters. Now, the input distance is how far we have to pull the string in order to do that. So if we measure that, the input distance is going to be 40 centimeters. So for pulley system number 5, we got the output distance was 10.5 centimeters. That's how far it lifted it up. But we had to pull the rope 40 centimeters in order to get that. All right, so that's our output distance, input distance. So now let's look at the input force. So input force is how hard we have to pull on the rope. And attached to here, we have a scale that gives us the force in grams and newtons. We are going to be using the newton side. And as we pull this pulley, the force required to lift this object is 0.5 newtons. So that's what you'll write down for the input force, because that's the force I'm doing. Output force, if you remember us saying this, output force is just the weight of the object. So if we take this object off and go to weigh it with a different scale.
I don't know how to play the game.
This particular weight weighs 2.5 newtons. And remember, the weight of the object is the output force, so you can put that in for the output force for the number 5 pulley system. All right, so that's our first pulley system we're looking at. I'm going to kind of pause the video as I set up the next pulley system, and then we'll continue. All right, guys, welcome back. I got our next pulley system built. This is pulley system number 4. This pulley has 2 fixed pulleys up top and then 1 movable one at the bottom. So for this one, we're still filling out the same parts of the table that we were doing, but this time for this system. We are using the same weight, and since we're using the same weight, that means that the output force is going to remain the same because output force is just the weight of the object. All right, so you can just copy that number down for there. For the number of strings going up in this particular pulley, we still have 2 strings that are moving up, so you can put that for that part. Now, input force is going to be how hard I have to pull on this And for this system, I have to pull with 0.7 newtons of force. So that's what I'm doing. So that means that's our input. So our input force is 0.7 newtons. So that's that part. The distances. So if we go to measure the distances, all right, so we're starting at 12 centimeters. If we pull on this, we are going up to 32 and a half. So we went from 12 to 32 and a half, which means we went 20 and a half centimeters. So that's how far the object was lifted. And so that's what the pulley is doing. So that's our output distance. So 20.5 centimeters for our output distance. Now, input distance is how far we pulled the rope for that. So if we get this situated, all right, we pulled the rope 62 centimeters. So our input distance, the distance that we are doing stuff, is 62 centimeters. And so that's what you should need for pulley system number 4, which is 2 fixed, 1 movable. So you can go ahead and do the calculations for that. I'm going to pause the video as I set up pulley system number 3. All right, so welcome back, those of you at home. This is pulley system number 3, which is 1 fixed pulley and 1 movable pulley. We are still using the same weights, so that means our output force is going to remain the same. So we're going to start by finding the input force for pulley system number 3. So something doesn't feel right here. Okay, so one of our strings came off the track there. So as we pull on this, it requires 1.3 newtons to pull this object up using this pulley system. So 1.3 will be our input force. Output force, like I said, is still the weight of the object, still the same object. So if we measure the output distance, so how far do we lift this object off the ground? So it's starting at 2.5. So we started at 2.5 and we went up to 35. So that means the output distance, we raised it up 32.5 centimeters. So that's our output distance, 32.5. So there's that. The input distance is how far we have to pull the rope to do that. Tommy, you want to come hold this real quick? Right there. Try to hold it as still as you can. Thank you. All right, so we had to pull the rope 65 centimeters in order to move that object. So that's our input distance. So for pulley system number 3, the input distance is 65 centimeters. All right, now if you look at the number of strings going up, in this setup, there's only 1 string moving upwards. So you can put that in for there. That should be everything you need for pulley system number 3. You just need to do the calculations from there. All right, guys, welcome back. We are on pulley system number 2. Pulley system number 2 is just involving 1 movable pulley. So it's no fixed pulleys on this system. Now, as you look at this, when we are using this one can kind of be a pain to use. You as well, guys. All right, so On this, we only have one rope that is being pulled up. You also notice that I actually have to pull upwards instead of sideways or downwards in order to get this to work properly. All right, so this one requires a slightly different setup than most of the other pulleys we've been using. So anyways, I'm going to pause the video real quick and then we'll... All right, so sorry about that pause there, guys. Mr. Disney came in, and so we're back to pulley system number 2. We said this is just one movable pulley, and there's only one rope going upwards. We are still using the same weight here, so that means the output force is going to be the same. Now, as I lift this up, this is requiring 1.6 newtons in order to lift it. So our input force, what we are doing is 1.6 newtons in this situation. All right, now, for the distances, I'm not going to lift this one as high just because I can't reach as high. So if we start with the object on the bottom, it's starting at 3 centimeters. And if I lift it up, it is now at 19 centimeters. So we lifted it from 3 to 19, which means we've lifted it 16 centimeters. All right, so that's the output distance, the distance the pulley lifted the object. All right, now, for the input distance, how far we have to pull the rope, we are starting at 55. And went up to 88. So 55 to 88 means we had to pull the rope 33 centimeters in order to get that object to lift that high with the pulley. All right, so that should be the input distance. So you should have everything now for pulley system number 2. So you can go ahead and record those and then make your calculations. I'm going to pause as I set up pulley system number. All right, guys, we're back for pulley system number 1. Pulley system number 1 is just one fixed pulley. There is no movable pulleys down here. We are still using the same object, so our output force is going to remain the same. So as we go to lift this particular object, it requires 2.3 newtons in order to lift this object by using this pulley system. All right, so that's our first part. The number of streams going up, it's still just one stream going upwards. So we got our output force, we have our input force. Now we need our output and input distance. So start at 3 centimeters. And we are going to 34. So we went from 3 to 34, which means our output distance was 31 centimeters. So the pulley lifted this object 31 centimeters. Now for how far we pulled it, hold on, this one's a little harder to measure. Let me turn this around. Okay. So All right, so for that one, we had an input distance of 36 centimeters. So if you record that, that is your input distance. We had our output distance. So I think that's everything for pulley system number one. You should be good now to do all the calculations and answer the questions that are there. Once you're done, submit it and you are good for the day. If you do have further questions, just let me know.